Welcome to the DIY Honda Garage channel. The error code P1658 indicates an ETCS control relay on malfunction, specifically for the Honda Civic models from 2016 to 2021. This Diagnostic Trouble Code, DTC, is part of the Powertrain Control Module fuel injection, PGM-FI system. The Electronic Throttle Control System, ETCS, plays a critical role in managing the throttle actuation in response to driver inputs, ensuring effective engine performance and efficiency. The relay circuit involved is responsible for powering the throttle control and enabling proper communication between the engine control unit, ECU, and other engine components. For this particular error, it is essential to assess the relay circuit functionality and check for any faults in its connection or operation. Addressing this malfunction is crucial for maintaining optimal vehicle performance and safety. The DTC P1658 pertains to the Electronic Throttle Control System, ETCS, and is connected to the Powertrain Control Module, PCM. The ETCS manages the throttle valve and influences the engine's air intake, crucial for performance and emissions control. The relay circuit acts as a bridge between the ETCS and the PCM, ensuring electrical signals are properly transmitted. Typically, you will find the relay circuit located near the PCM, encapsulated within the engine compartment. The PCM, or Engine Control Unit, processes inputs from various sensors to regulate engine operations. A malfunction here may hinder throttle response, impacting vehicle drivability and efficiency significantly. It is vital to diagnose any faults within these components to restore the system's proper functionality. Understanding the potential causes of DTC P1658 aids in effective troubleshooting. Firstly, poor connections can lead to intermittent failures. These may manifest during specific operating conditions where vibrations or thermal changes provoke erratic behavior. Secondly, an intermittent failure signifies that the relay circuit appears operational during one test, but fails under different circumstances, indicating a likely unstable component. Another common cause is a faulty relay circuit board, which might damage the components or circuits responsible for transmitting signals between the ETCS and the PCM. Each of these potential issues must be verified through a systematic approach, ensuring that all probable causes are examined before replacing any components. Symptoms associated with DTC P1658 can adversely affect driving experience and vehicle reliability. Delayed throttle response is a primary indicator, manifesting when the driver accelerates, but there is a noticeable lag before the vehicle reacts. Another clear symptom is the illumination of the check engine light on the dashboard, serving as a warning of underlying systems not functioning correctly. Additionally, drivers may experience inconsistent engine performance, characterized by fluctuations in power delivery, idle stability, and overall responsiveness. Recognizing these signs early is crucial. Otherwise, they could lead to more profound implications if the underlying cause remains unaddressed. For the first troubleshooting step associated with DTC P1658, begin by turning the vehicle to the on mode without starting the engine. This allows the modules to power up and prepare for diagnostics. Next, employ the Honda Diagnostic System, HDS, and select the ETCS test located in the inspection menu. The intention here is to verify whether the relay circuit is functioning correctly. If the relay circuit returns a positive result, it may indicate an intermittent failure, prompting you to inspect for poor connections or loose terminals at both the relay circuit board and the PCM. Should the DTC be recorded during this process, it would be prudent to attempt to replicate the failure under the same conditions noted in the onboard snapshot. However, if the circuit is not okay, you will need to proceed to the next step in the diagnosis. Transitioning to the second step. First, ensure the vehicle is turned off, placing it in lock mode. This means all systems powered down to safely perform your checks. Once in this mode, remove the relay circuit board for assessment. Testing the relay circuit board is crucial as it holds the circuitry responsible for connecting the ETCS and PCM. Use testing equipment to ensure the relay circuit is functioning as designed. If the components exhibit failures, replacement of the relay circuit board is warranted. If the relay circuit board passes the test, you will need to advance to the next troubleshooting step to ensure all potential issues are thoroughly evaluated. In the third troubleshooting step, begin by jumping the SCS line, short connector system, using the HDS. Allow the system to stabilize for more than 1 minute to accurately capture any short circuits. Next, carefully disconnect the PCM connector A, which is a 50-pin connector crucial for signal communication. With the relay circuit board removed and the PCM connector disconnected, check for continuity between the specified test points. Test point 1 is found at PCM connector A, number 25, and test point 2 is directed to body ground. Should there be continuity, this indicates a short in the FI sub RLY click wire between the PCM and the relay circuit. If no continuity is found, it implies the FI sub RLY click wire may still be intact. Hence, you would then progress to the final wire checks. For the last troubleshooting step, ensure the vehicle is in the on mode, allowing the systems necessary for testing to activate. With the relay circuit board still removed and the PCM connector A disconnected, you will now measure the voltage between two specific test points again. Test point 1 is at PCM connector A, number 16, while test point 2 remains grounded to body ground. It is crucial to confirm whether there is battery voltage present at this stage. A positive result indicates a potential short to power within the FI sub RLY outwire that connects the PCM to the relay circuit. Conversely, if no battery voltage is present, this points to a functioning wire. Therefore, it is advisable to explore authorized service information for related DTCs or symptoms, or consider substituting a known good PCM to ascertain if the original PCM needs replacement. After conducting all necessary repairs and component replacements, rechecking immediate DTC codes is vital for confirming the effectiveness of all corrective actions taken. Ensure that any disconnected components, such as the PCM and relay circuit board, are reconnected securely following the manufacturer's specifications. Conduct a thorough performance test on the vehicle, checking throttle response, engine performance, and that no additional warning lights illuminate on the dashboard. A successful outcome where no DTC recurs and the vehicle operates smoothly signifies that the issue tied to DTC P1658 has been appropriately addressed. Documenting the repairs made and outcomes achieved is crucial for future reference and for maintaining service history. In order to prevent the recurrence of DTC P1658, routine inspections of the ETCS and its connected components are highly recommended. Regular checks for electrical connections, including ensuring that terminals are not corroded or loose, can preempt many wiring issues. It's wise to schedule these inspections as part of vehicle maintenance, especially for safety systems. Additionally, only using quality parts during any replacements or repairs can significantly reduce the risk of future malfunctions. Always refer to authorized service manuals for exact specifications when servicing these components. Consistently following these preventive maintenance steps will mitigate the risk of similar issues arising, leading to improved vehicle reliability overall. To conclude, the diagnosis and troubleshooting process for DTC P1658 requires a thorough understanding and systematic approach to identifying faults within the ETCS and relay circuits. We have highlighted various key troubleshooting steps, including verifying relay functionality, ensuring no shorts in the wiring, and testing the system comprehensively. Accurate diagnosis is paramount to successfully resolving the underlying issues, thus restoring proper engine function and throttle responsiveness. Moreover, preventive measures such as routine inspections and using high-quality parts can significantly reduce the likelihood of future occurrences. By adhering to these practices, you will ultimately ensure the safety and performance of the Honda Civic while fostering its longevity on the road. Please like and subscribe to the channel. See you next time.